Good afternoon and welcome to our webinar this afternoon. It's long awaited, in my opinion, because I have wanted to host this webinar for quite some time, and I was fortunate enough to finally get our presenters to find some time that they could carve in their very busy schedules to be able to present this for you. This is a Victoria Beale with the Ohio LTAP Center, and I have our presenter Adam, who will be speaking to you about the evolution of recycled plastic roundabout design. And I will tell you on the poll question that's up that I'm the one that actually put the grammatical error in there. So it should have been, have you heard of modular roundabouts? And I made the wrong word, plural, in there. So don't let that be a reflection on your speakers because they are excellent at what they do. And I am so excited we're going to be able to host this webinar for you today. A couple of very quick housekeeping items, then I'm turning it over to Adam, who will introduce himself and also his colleague, Jerry. First off, there's a section in your GoToWebinar panel that says questions. That is where we'd like for you to ask questions of the presenters. So if you could take a second, and if you haven't, had the opportunity yet, please drop a hi or hello in there, especially if this is one of your very first times with us on a webinar, because we want to make sure you know where to go to put your questions in. Secondly, there is a handout in the handout section of the GoToWebinar panel. And if you have a problem downloading that, don't worry. We will be able to email that out to you afterwards, along with hopefully a link to the recording of today's webinar. So this is information I learned about 2 years ago at our Roundabouts conference, and I have been, really excited ever since about this concept. And I know that when Hillary Isebrands, she was there present as well. She spoke about how this is a research project that Federal Highway has been working with Adam and Jerry on. So I want to make sure they have plenty of time. So I'm going to be quiet now, turn things over to Adam. Here you go.
All right.
Oh,
Great.
and I should take that poll question down, shouldn't I? I'm sorry. Let me close that up, and
Okay.
I'm going to share the results real quick.
Okay.
So final results, we have 26% that have heard of the modular roundabouts before, but 74% have not. So this is going to be brand new information for 74% of you. Please make sure you ask lots of questions. There we go. Thanks.
All right. Thank you, Victoria. I appreciate that. I'm usually responsible for spelling errors, so that could have easily been me. Well, thanks everybody for joining today. We appreciate so many people coming out to listen to what we've been doing here with the modular recycled roundabouts. We've done quite a bit here in the last few years, and we're anxious to share that with you. Just a quick background on myself. I'm an engineer. My primary disciplines are composite materials and polymers. I've worked in the aerospace and defense industry for about 13 years now, most of that with Jerry. And we primarily deal with programs that originate from a program that the government does called SBIR, which stands for Small Business Innovative Research. And Jerry and I have done a lot of those programs on the Defense Department side, but every now and again, Department of Energy, Department of Transportation, and such, they do publish some pretty intriguing solicitations, and one of those happened to be the recycled plastic roundabout. And so we kind of went into that program and won it, and this is kind of the evolution of how that happened and where we are now. Jerry, if you just want to say a couple quick words, introduce yourself.
Hi, this is Jerry Fanucci, and Adam gave a lot of the background. We've been working on this project since, I think, 2014, so it's nothing new now, but we keep improving it with each new installation, still getting R&D funding from DOT. The company itself does, this is our only real civil engineering program. We're more defense and aerospace, so it's quite a different kind of environment for us, but the same basic ideas apply. Pick the best material, figure out how to make it, figure out how to employ it on the ground, and make it work. So I don't want to take up Adam's time. He's got a lot to say.
Thanks, Jerry. Appreciate it. All right. So the clock started. Okay, so I'll start here. just go over a quick review. I don't know if everyone here is really familiar with why mini roundabouts are typically used, or why the USDOT thinks they're so great. But I'll just go over a quick review of kind of the general concept of mini roundabouts. So the primary difference between a conventional roundabout and a mini roundabout is that you know, they're smaller, so they're gonna work in a lot of different intersections that perhaps a larger, more traditional roundabout wouldn't work. And because of that, some of the vehicles that enter them, such as semis or buses, the larger, longer vehicles that need a bigger turn radius, won't quite make it through there, and so they're going to have to traverse over the island, as you see there in the picture to the right. And so that's the primary differentiator between that conventional and mini roundabout. So why does the USDOT like mini roundabout so much? Well, they've done a lot of studies on these, and the data kind of shows a resounding consensus in that they do tend to increase throughput versus four-way stops, and in some instances traffic lights, and that's obviously dependent on a lot of factors, but in general that they do improve traffic flow. They also generally reduce accidents, and definitely reduce significantly severe accidents. So instead of traffic fatalities, you're going to see more property damage type incidents where people are walking away instead of getting into an ambulance. And then also because the methodology of a mini roundabout is that, you know, the driver gets to decide one thing at a time. So he sees the pedestrian first, deals with that, then goes to the intersection, deals with that. It makes it safer for pedestrians and bikes as well. And then pedestrians get to deal with one lane of traffic at a time, have refuge, and then deal with the next. So in general, just a safer, very efficient system that's gaining a lot of popularity around the United States. And then, you know, just as an idea of how big this market could potentially be, you know, we've seen a number that's been thrown out to us of about 500,000 locations in the U.S. that could benefit from being converted to mini roundabout. So that was a pretty compelling number to us, how much we could impact the country in terms of safety and efficiency. So with this SBIR program that we delved into, there was 3 primary targets there to kind of help proliferate roundabouts into a wider spread use throughout the U.S. and kind of tackle some of those 500,000 intersections. And that includes, you know, decreasing that installation time. I know this is kind of a widespread range in terms of how long it takes, but I've seen anywhere from, like, you know, 4 weeks up to 6 months, and maybe that's not all the installation portion of it, but some of these can be pretty lengthy in time. Another one is they wanted to reduce traffic disruption, and so instead of, you know, having concrete where you're gonna have some issues with being able to drive over immediately, or have a certain amount of days you have to wait, some pretty significant construction is required there. And then also wanted to drive that cost down so you could employ more roundabouts with the same amount of money, or even, you know, further beyond that. So those are our primary targets for the first round of funding there, and yeah, we were striving very hard to obtain those. So some of the advantages you see for the modular approach versus a conventional approach. First is we don't really have to modify the roadway at all. We go right over the top of it, and then the system attaches right to the existing asphalt, which helps in multiple ways in terms of speed and in terms of cost. We can be up to 50% less than traditional materials. That's obviously dependent on a lot of factors, but there's definitely a lot of cost benefits to this approach. And we can also be much faster to install, depending on, again, a lot of those different factors. But again, this lays out very fast, and then it's very linear in terms of how fast you want to get it done. If you want it to take a little bit longer, you put less people on it. If you want it to go really fast, you just put more people on it, and it can get done faster. So lots of benefits there. And then also, as we mentioned earlier, you can drive over it during the installation process, which minimizes rerouting and just general aggravation for folks trying to get about their day. The installation process is actually quite simple. We'll go over that in details here in a little bit, but anybody can do it. There's videos, there's documents that kind of show how to do it, and it's pretty basic, uses basic tools. And so far we've had a lot of maintenance crews for different departments of transportation kind of tackle this installation with fairly ease. So it's been interesting to see how that has progressed. The materials are durable. We've designed this with the long term in mind. We're borrowing kind of a basic material technology that's used in railroad ties. These materials were actually developed for that, and then we've kind of borrowed them over to this application. So these are designed to have like a 50-year life, you know, against rot, bugs, general wear and tear, UV, all the environmental factors. Very stable, very robust. They're easy to repair too. So if you've got infield issue, you know, snowplow hits it or something happens, it's pretty simple to replace. You just need to remove some of the hardware, remove the board, and then put a new board in, and you can move along. It's been pretty easy so far. So that's a good benefit that we've seen. And then also, these can be permanent or temporary. We've seen both. We've seen some where they start temporary and they, you know, just kind of convert to permanent because they're working and people are adapting to it and really liking it. And then lastly, it is a green solution in that, you know, the boards are made from 100% recycled materials. And it doesn't cost extra. Usually green means it's going to cost more, but really we're striving to cost less. So it's kind of an added bonus. And so far we've seen on average about 375,000 of those 1 gallon plastic jugs get repurposed into the middle of an intersection instead of in a landfill or floating around in the ocean somewhere. So all great advantages there. Do a basic review of the system components here. Pretty basic, pretty simple. We've got 3 major things. You've got the modular boards, and those again are that plastic material that we borrow from the railroad ties, and those are between 2 and 3 inches thick, depending on a lot of factors, and that's kind of variable that the designer can choose. And then we basically CNC those from a stock material that we have into the desired shapes that we need. And then the anchor system is pretty straightforward. It's an anchor specifically designed for asphalt, so it's got a pretty long reach because asphalt's typically weaker than a concrete, so it needs a little bit of special design there. And we use stainless steel, and we have other flavors available in that. You know, if you're in a basic environment that's going to have a long-term projection, you're going to want to look at 304 stainless. If you're in a marine environment, 316. If you got a short term, we could go with galvanized. So we've got options there. And then we basically use a quick setting anchor cement to install that anchor, or an adhesive for special situations. Adhesive usually costs a little bit more, but there are special situations where it's more effective. And then you have the basic hardware that attaches the boards down with bolts and washers. And then that plug that we use that does the final hold down or interfacing of the board to the anchor, we specifically designed, and I'll go into some of those details later. But in general, we have some that are flush with the board. So if you do need to get on top of that surface, you don't want to drag anything, or if you just want a more long-term solution that's protected, we recommend that. We also have what we refer to as the mushroom cap, which basically has a domed feature on top of the board. It sits on top. And that creates a little bit more visibility for drivers. And you can see here in this illustration to the right here that all those little circles there, the yellow circles, are all those domed caps. They're about 5 inches in diameter. And all those are injection molded with a high-end engineering elastomer. It's a urethane, very, very tough material, high abrasion resistant, UV resistant. Basically the highest class material in the elastomer category. Let's see. So we'll go over the general installation process. There's 7 steps that starts from, you know, conception to final installation. So step 1, we're gonna look at that design, and typically what we'll have is the municipality will work internally to develop it, or they can work with the designer, or we have connections that folks who can do that too. So it's basically just developing the general concept, and then that concept gets handed over to us, and then we take over. We don't do any roundabout design. That's not really our forte. And then what we do is we modularize it, and we'll develop a three-dimensional CAD file and drawings, all that stuff, and then we come back to the municipality and say, or the customer, and say, hey, does this meet your requirements? Does this look good, et cetera? And then we get final approvals. And then from there, we go to the manufacture and delivery of the system. So we start with our stock structural lumber. We take our CAD and we CNC machine that into the final shapes. And so basically what you have is all the angles are cut, all the edge details are applied, all the through holes, everything. It's a complete system. There's no there's no modifications that need to be done in the field. If something's wrong or there's a hole or something is unexpected in the field, easily modified. But as they come, it's ready to go right from the kit, and then that gets put in what we call a smart kit, and that kit is stacked in the order that it needs to be used in the field, so it makes installation fast. The pallets are color coded, they're ID'd for fast staging in the field, so you know exactly where they go to which island, and then each board is individually numbered as well. And then we have the anchor and cement and the hold down plugs, those get palletized as well. All those pallets get put onto a truck. We have some installation instructions that go along with that, and we ship it directly to the customer wherever the site is going to be. And then basically from that installation packet, you see here's a page right out of it, and this kind of shows the general layout of the roundabout. And so you have your color-coded pallets that show up, and then you have your basically roadmap for where those go. So all the green pallets are going to go to these 3 roundabouts, and then depending on which numbers they are, they will get divided out appropriately, and so on and so forth. So you have all the red pallets here, blue pallets here, orange here. So it's very rapid. It's very straightforward. It's similar to like an IKEA kit where everything's just very simple, straightforward, and easy to wrap your head around for installation. Stage 4, once you have everything staged, basically you'll go ahead and open up those pallets, and then you'll start laying out the boards. And this step goes pretty fast. Usually an hour to 4 hours, depending on the size. Like a center island would probably take about 4 hours, but one of the smaller islands would take anywhere from 1 to 2 hours. Once those boards are into place, you'll basically apply what we call spacers, and those allow us to have a thermal expansion buffer, so that if you install it at 50 degrees and it gets to 120, it can grow without warping, and then also allow watershed as well. And then you have to secure the outer edge, and basically it's pretty simple. We just use a 2x4 and some asphalt nails, and then once it's to that point, you can drive over it and nothing moves. And then it's stable and ready for drilling. So I'll just show you a quick video here. This is from an installation we did like a month ago over in Richmond, Virginia. It's in fast motion. Oops, I suppose I should use this. Let's see. Hopefully everybody can see this. Any high-level instruction on that. And then basically we go into drilling holes, and this procedure is pretty straightforward. We provide a custom drill guide, and that will mate.
You'll need to reshare your screen.
Oh, sorry.
Sorry.
There we go. See it now?
Yes.
Okay, great. Yeah, so we'll provide that custom drill guide, and that will mate with the pre-existing pre-drilled holes. And it perfectly aligns the drill, so you just have to focus on pushing down on the drill, and then once you're done, actually it's designed to mate with the hammer drill bit, such that when you lift it up, it actually picks the guide up for you, and then you go to the next hole and you can repeat. And then basically all you have to do is vacuum out the debris that's around the hole and inside of it, and you are ready for the next step. And this step, basically we're installing the anchors. And it's pretty easy. You have a basic anchor cement, which is fairly low viscosity. It's very similar to like a thick motor oil. Mix that up, you pour it in the hole, and then you basically push the anchor in, and then you see in that picture in the lower right, you see a little bit of spill out. That's when you know you got it right. And then you let that sit for anywhere to 2 to 4 hours, and then it's ready to move to the next step and complete the installation. And then the final step here is just simply removing that bolt that was that stayed inside the anchor during installation, so you don't get any cement inside of that in the thread. So remove that, drop the plug into the hole. It's perfectly designed to mate with that, and then push the bolt through, screw it in, and it is all complete. And then we have a step I call 7+, which isn't always necessary, but sometimes, you know, things happen in the field that weren't anticipated. Things are there, things aren't there, measurements aren't exact, so on and so forth. You can basically use any tools that would work for wood, would work on this stuff. So for instance, some of the manholes weren't marked when we did the job up in Canada, and we had to field modify. Just used a Sawzall, cut a circle around it, had access to it. If you ever need to cut a board to a different size, you can use hole saws to drill new holes for plugs, fairly simple. And then this one in the lower right, this road was that high heavy traffic load, 200 trucks a day, and they had huge ruts in it, and so it created a really steep peak, and we had to just kind of cut down the center, created a new hole there, and we're able to just recover from that kind of unforeseen issue. Okay, so I got a quick video here, just gives you like an overview of kind of the whole process. I think it's a little over a minute long, and we'll just take a look at that here quick. And it does have audio, so if you want to adjust your audio down a little bit, it's just background music.
So Adam, if you're talking to us, you're muted. You'll have to unmute yourself and then share your screen again. While Adam's getting that situated, I know that there have been questions coming into the question box, and I have been sending those over to Jerry to answer. So he's going to be responding to those. Hey, Adam, it still says that you've got yourself muted. Well, there you go. Now we can hear you.
There we go.
Great.
It was frozen there for a second. I couldn't do anything.
You love technology, don't you?
I know. Excellent.
All right.
So we're back.
Remember to reshare your screen.
Yep.
Thanks.
Okay, excellent. Okay, so just a quick timeline of kind of the evolution of how this started and where we are now. So started in mid to late 2014 there with that phase 1 proposal for that SBIR. And we started that program early 2015, and then finished mid to late 2015 with that first prototype, which wasn't a full scale. It was about 3/4 size, but it was pretty substantial, and it was in a lab environment only. And then 2016, we submitted a phase 2. We were awarded that, and then that primary thrust for that program was to get real full-size modular roundabouts into the field. So immediately we went ahead and did the speed bump surrogate, which I'll go over here in a little bit. That kind of helped us with the immediate testing. And then kind of in between our surrogate and our first installation for the SBIR, we actually got our first commercial order. When that was for Canada, and they had special reasons for why they wanted to do that, even ahead of it ever being tested in the field before. And then shortly thereafter, we went to install in Jackson, Georgia. That was our first SBIR-related installation. That was kind of the demonstrator, and then we did a follow-up there in Annandale, mid-2018. And then we had a small brief period here between mid-2018 to mid-2019 where we started collecting data, seeing how everything performed to get a better understanding of what needed to be improved, what people's gripes were, and just kind of refocus the energy to improve the system for the next generation. And so we wrote another proposal, and that's where we're at now, is kind of this phase 2B. And then the plus option is something slightly, it's related, but I'll get into that a little bit. And so the main thrust for this was, again, to reduce anchor count, reduce time to install, and also reduce costs further. So we basically took our lessons learned, applying it there. And then since then, we've had some commercial activity with Richmond, Virginia. We're currently installing 3 there. We had a patent issued late July of this year. So that was exciting to see that come through. And then we have our San Diego demonstrator for kind of the new technology coming in mid to late 2020. And then we also have another commercial install up in San Francisco. And then we've had a lot of interest. We don't really advertise much, but we've kind of had a lot of word of mouth interest, and we've got about $2 million in proposals and pending activity out there. So it's been exciting. Things are kind of growing, and it's kind of catching on everywhere, and we're excited to see the growth of this happen. So I'll start with just some little case studies on each of the installations we did and kind of what we learned from each. So this was that truck stop. This was that demonstrator or surrogate that we used up in Bozeman. It was basically a speed bump, and you can't see the layout of this gas station, but essentially the trucks had one way to get out of the gas station to get back to the interstate, and we put the speed bump in that path so we could get a lot of impacts a day. So we mounted a trail camera up on that light post you see on that picture to the left, and we count how many trucks were going over it. And so we're seeing about 50 to 70 a day, pretty heavy use. It's cold and snowy up in Bozeman, so we saw 2 winters while it was installed. One of which was, I guess, the coldest in 40 years. Average temperature was like 2 degrees, so it saw some significant environmental conditions. And so in general, we didn't see any loose panels, didn't really need any repair or replacement for anything. We did have some issues where the snowplow had impacted on a few spots, but it really just resulted in some divots in the material, but it still functioned as intended. So that was nice to see that be successful. We ended up removing that in April 2018. The truckers were getting a little sick of it by then. Then we fast forward to the commercial installation in Alberta. Again, another pretty tough environment for 2 reasons. Obviously the winters are pretty tough up there, and then also this road was the heavy load, wide load corridor to basically all of northern Alberta, where the oil fields are and the forests up there. So a lot of loggers and oil rigs and stuff coming through. We saw anywhere between 10 and 20 wide loads come through every single day during construction, and probably I would say close to 200 semis travel down this road every day. There's a lumber yard or a raw lumber yard on one side, and they basically go through town every day. And it was pretty intense. Lots of big divots in the road from those trucks coming through. But they could not close this road down. They needed it to be open, and they could not reroute this traffic anywhere else. So that's why they went ahead with our product, so they could keep that roadway open during construction and allow those heavy loads, wide loads to get through. Total of 6,000 square feet between the 3 intersections. They were all adjacent to each other. So 2,000 per intersection. We had a 5-man crew, and it took about 13 days to do all 3, and that was with a few weather stops. We got lucky. It was late October, usually pretty bad time to be in Alberta anywhere, and Sundra's north of Calgary. So we had a couple days where we had some snow and some cold nights, but we were able to get it done in 13 days. And interestingly, our first project ever, we from contract award to installation complete, we did it in 2 months, which is pretty remarkable, given the uncertainty of everything. And then we fast forward to that Jackson, Georgia installation. Jackson's about an hour and a half south of Atlanta, southeast-ish. And had an intersection there. It was like a rural highway that crossed kind of like 2 feeder roads. I believe there is a lake to the east, and then just a general bigger population to the west. And it was a 4-way stop, and they just had some accident issues there and some trouble at peak times getting people through there. That was a fairly small one, 1,500 square feet total. We had a 3-man crew. That one was a commercial crew that we actually hired through local staffing agency, and that took about 7 days to install that one. Then we go to the Annandale, Virginia one. This one was the largest we have done to date. Annandale is just outside of DC, maybe like 20 miles west. Fairly populous, densely populated area, but more suburban-ish. It was a busy road, pretty high speeds. It was a 2-way stop. The main thoroughfare, which is what you're looking down in the picture, had pretty much the right of way, and all the feeder streets to the left and right there had trouble getting in, especially during peak traffic. So, and they also had some, I believe, some traffic fatalities and maybe some pedestrian here that they wanted to kind of remedy. But yeah, big roundabout, 6,800 square feet. We had between 10 and 15 people on site during the day, and it took us about 9 days to install this, have it fully functioning. One interesting thing we saw in the Jackson, Georgia one, was a fairly small one, was that they ran into an issue with their design. They presented their design, and they found that after gathering some data that the behavior of the traffic coming through there wasn't quite ideal for what they wanted. Their intended designed 85th percentile speed was 15 miles an hour, and they determined that would be a good speed to kind of get everyone in the roundabout to trust the oncoming traffic, and to create flow and to reduce any chance of accidents. But what they were seeing was 19 miles an hour, which they didn't really like. And so we came up with an approach to where, since this is a modular material, we could apply the modular system over the existing to kind of create a new geometry and maybe change the behavior of the traffic. So what we did was basically ovalize the roundabout slightly to kind of push that traffic out a little further, make the fastest path a little more tough to navigate, slow those guys down. And so basically we added about 2 boards widths on the one side of the roundabout, and then removed 2 boards from that one splitter to give semi trucks enough space to be able to navigate that. And we provided those boards, and then GDOT, their crew, installed it. They had never installed because we previously used our own people to install this one. So they picked it up really quick. Took about a half day to do this modification, and I think it was around $2,000. So pretty cheap, pretty fast, and we got some pretty interesting results. I think everyone was happy. So in general, the result was that the traffic did slow down. It was as intended. And just to be complete and fair, I wanted to provide some of the test specifications. So basically, we did do all of the recording of the data mid-morning, so we wanted to keep that consistent. And then we tried to keep the days similar weather, so we, it didn't have like a rain effect or something. So this 8/22 date is the before modification, so the modular roundabout's installed, but it's not modified yet. And then this 10/15, it was the first measurement after modification. January 14/20 was the second after modification. And the reason we did that second one is because we wanted to see if the local traffic maybe became used to it and then modified their behavior based on that. So what we did find is that, pre-modification, that 85th percentile speed was about 19 miles an hour. And then shortly after post-modification, they saw a 13 mile an hour 85th percentile speed. So they had achieved their target just slightly below it, which was nice to see. And then they came back another 3 months later, which is, I think, almost a total of 6 months after original install. And so it did slightly creep up a little bit, but still really close to that targeted speed. So that was really interesting to see how, if you have an apprehensive community or if you have a design that doesn't exactly work, it's very simple and easy to remedy that issue with this modular approach. So some next generation design stuff we're working on right now to kind of expedite the install and reduce the amount of anchors you have to put in and reduce some of the cost is this kind of intermodular connected system. The goal was we wanted to reduce the anchor count because I know a lot of people that did the installation didn't really like the anchors as much because there's a lot, and it was kind of a tough thing to do. It's very intensive on the body. So we want to reduce that for cost and time. And then also, so you can see feeds into this time target and then also this cost target. So basically what we do is we interconnect the boards and then we only strategically anchor a few of the boards. Now, it doesn't necessarily have to be this configuration, but it's just an example. And then what you do is you basically leverage the strength of the entire system with using less anchors, but effectively it acts as more because now this outer board gets to leverage these anchors as well, even though net overall there's less anchors. So the other kind of cool feature is that in plane, this is very stiff, so it's able to transfer that load to and fro. But out of plane, it's actually flexible, so you can actually roll it up similar to like a rug or something. And then we package those up, deliver them to the field, we stage them in place, basically unroll them, and now you've done a large section fairly quickly, and you only have to do a few anchors to kind of expedite that process. So that's one of the areas we're working on. We're also looking to improve the visibility of the system. It is pretty low profile, so anything we can do there is of importance. We do use bright colors around the perimeters typically to kind of help with that, but we're looking at some other options using reflective tapes and reflective markers to kind of improve that. As mentioned earlier, alternatives to the anchor cement using adhesives. As we saw in Sundry in Canada, we had some issues with cold weather where the anchor cement's kind of at its limits, and there are definitely adhesives. It's right around 40 degrees F is where the anchor cement starts to have problems, and there are adhesives that go down to, I think, 14, or there's some that even go down to 0. But I doubt people are going to want to be working at that temp, but if they do, if there's an emergency, we have a solution for that. And then also we saw in Virginia, I don't know if it was due to a large amount of rain recently or a really high water table or a leaky water main, but we had some instances where we drilled into the road and the holes just kept filling up with water. So it was a little troublesome with the anchor cement, but there are adhesives out there for anchors that can cure and function completely in fully submerged water. So those are a couple new developments we're working on. And then we just wanted to improve the system robustness overall, reducing the load transfer to the bolts. That's critical for longevity and reducing damage during kind of extreme events. Wanted to improve that corrosion resistance for longevity, and then also wanted to improve impact absorbance because there's a lot of situations where you just don't know what's going to happen in a roadway in terms of how fast the vehicle is going to be going. The posted speed limit could be 30, but they going 50 or something, and you have to account for that. But if you did it with a straight design, you'd have 6-inch diameter anchors or something. But we wanted to keep costs down and then try to just absorb a lot of that energy instead of just fighting it directly. So we've done a lot of subsystem lab testing here on a lot of the different areas we're looking at. First, we looked at these plug tests. And the idea here is that we want to absorb a lot of energy in those kind of outlier situations where there's a hard impact or something that's kind of out of ordinary. So what you're looking at here in this picture in the center is you're looking at the bottom of the board as if you're in the road looking at the bottom of the board. And so the anchor is that threaded bolt, and the black circle is the plug. And so this is pre-test. And then you can see in the slightly lower right corner, it's completely extended. It extends out about 2 inches, completely deforming and absorbing a lot of energy. And then eventually it allows the bolt and the washer to pass through that hole once it deforms to a high enough amount. And then the bolt, the anchor, the washer, and the plug, none of them are damaged post-test. And so the idea here is we'll never be able to stop, the big semi that comes in and, I don't know, plows into it or something. But the idea here is to create the cheapest, weakest link, and that if something's gonna break and you need to replace it, make it the cheapest and easiest thing to do, and that would be the plug. And so that's kind of what we did. And luckily, we actually got it to where the plug doesn't break either. So you just have to kind of reassemble in one of those really, strange high energy impact situations. Typical, just traversing the board, not a problem. This doesn't even feel anything really, but it's just those really outliers type situations, what we're kind of trying to design for here. And then we're also doing connector testing on the various connectors we're going to look at to kind of dial those in. Various anchor tests, including the ones we already use, and then other ones that we're looking at to help speed up the process. We're doing kind of an interesting full board test. We're actually censoring this whole board system to look at a lot of the different variables that we were going to see in the roadway. We've got accelerometers on here. We've got strain gauge bolts, all sorts of ways to collect data to see how the different variables affect it. Things we can't control: impact angle of the vehicle speed. We just want to see kind of general trends there. Edge detail geometry, that greatly dictates. I know there's competing forces here. Typically, a designer is going to want that as blunt as possible. In terms of survivability of the system, you're going to want it a little less blunt. And so we can see, how those different edge details are going to affect the system longevity. And then also connector type, how those affect how the load's transferred to the various bolts and such. And then also how that plug design, that high energy absorbing plug, how those are going to affect the system. And I know this last bullet here, a lot of folks in the Midwest who are interested in this have a lot of apprehension about snowplows. And we plan on doing some snowplow testing. We don't know exactly how that'll turn out, but that's why we're going to do the test to see exactly what happens when we plow into this, either at a glance or directly at it, as if somebody didn't see it at all. So we'll be happy to share those results once we get that testing done sometime later this summer or early fall. So I just got a quick video of that plug test. It's pretty pretty interesting to see live. I'll see if I can get this up here. Tune it such that we have the pull-out load just below the max load for the anchor, so the anchor never gets pulled out. That's the goal, because that's a little harder to replace. So we want to try to keep that as easy as possible in that high or low probability event. Share. Okay. So why a rubber plug, not a metal plug? So I just want a quick illustration of what's important to us here. So if you think about a metal plug, it's gonna be very stiff, and your anchor has a functional limit to how much it can hold into the ground. That's usually dictated by the strength of the asphalt. And our 2,000 pounds is based on a 3-inch asphalt, and I know roads are usually thicker than that, so that number is probably much higher. But we try to be conservative in our estimates. So if you were to use a metal plug, it would achieve that load very fast. And so if you think about energy absorption for high impacts that you'll probably see in a roadway, you don't have a lot. The area under the curve is kind of what your energy absorbed is. Now, if you look at an elastomeric plug, you're going to get a lot more elongation, out to that 2 inches before it obtains that load, and we can tune it to fail at whatever load we want, depending on which washer we use or what material hardness we use. So we can really manipulate that to exactly what we want it to do. And so it kind of plays into our ability to absorb that impact instead of kind of just transferring it to the bolt. We're trying to protect that anchoring system as it's the most important aspect of this system. So some other kind of next generation R&D activity that's part of this program we're doing. That San Diego install is going to be the R&D demonstrator for a lot of those concepts I just talked about, the interconnected pieces, the new plugs, new reflectivity, a lot of those different aspects we're going to try to deploy here at this this roundabout. Just to give you some size perspective, the center island's about 50 feet in diameter, and it's going in Balboa Park area. I don't know if anyone's familiar with San Diego, but it's a fairly decent intersection. One leg's 50 miles an hour, a couple of the other ones are 30, so it should see some decent traffic. We should learn a lot from that. Another aspect we're looking at that got a lot of interest lately was bike lanes and delineators. We had previously tried this and didn't have as much success because our system just wasn't really designed for a single board width, just kind of be floating out there. But we're actually pretty aggressively pursuing that and hope to have a product out that functions well, and we'll be testing it here in San Diego. And then we're doing some stuff with DoD. That was kind of that plus option stuff that I was talking about earlier. We're looking at expedient roundabouts for OCONUS and FOB bases for the military. So that's outside continent of the United States, and then forward operating bases. So I was in the Army previously, and I was on Camp Bonsteel, and there's about 10,000 people. It's literally like a small city. So they definitely have traffic problems there too. And then another interesting aspect is the autonomous vehicle interaction stuff. From what I understand, autonomous vehicles have trouble with roundabouts. So we've done some study and investigation into how we can better serve that, either through a modular system that's smart or other methods to do that. And then another kind of interesting one is through FEMA. There was kind of a unique application of roundabouts during a hurricane, I believe it was in North Carolina, where they set up temporary roundabouts because the power was out for about, I think, a week. And they basically just used orange cones and then had to have cops sit in the middle to kind of direct and create a deterrence for people. But we're working on coming up with a solution there where they can install something in a couple hours with no power to set up these kind of makeshift roundabouts during an emergency. So that's another area we're working in. Some current commercial activity, as I mentioned earlier. We're doing those 3 roundabouts in Richmond, little southwest, kind of like suburban areas. You can see a lot of the homes there built in that area, so a lot of traffic coming through there. We're going to do 3 there. Kind of fun to see another, 1.5 million milk jugs being repurposed over there. So I think that brings our total to about 3 million. So looking to achieve $1 billion here in the next 5 years. So hopefully we can obtain that. First one we did, this one's completed already. This was back mid-June. This was designed by JMT. It's pretty unique design. They wanted to keep the costs low because they have a lot of these they want to do, a lot of unsafe intersections. This one had unfortunately a pedestrian and a vehicular fatality in the last 6 to 12 months. So it was quite urgent to get this down. The community was really demanding it. So they kind of came up with a unique design where they use a lot of paint to drive people towards where they want to go on the approach. But then as they approach, they used our structure to really create a physical barrier. So they really had to follow what they were doing. So the upper right there is the design as drawn. Lower left was the intersection before, and then the lower right is the intersection after. And that took about 12 days. That was 5,000 square feet, and the VDOT maintenance crew did that. Very little instruction. They picked it up really fast. I was there for this one. They're doing the other 2 on their own, but it was quite hot, 95 degrees every day, 90% humidity. It didn't help with the speed. I'll tell you that. Here's another one. It's very similar in nature, using a lot of paint to kind of guide people in. And then using our structure to keep them there as they approach the center island. And they also did kind of a unique feature here to save a little bit of money. This is donut approach, where they did this turn radius study, and they found that no one was really turning over the center. So they said, well, why do we need material there? so we removed it, save a little bit of money there. And then basically, they've started this one, another 5,000 square foot one. We're estimating it should be about 10 days for them to get this done. They're about halfway done with it right now, and they should be done here probably by the end of this week. So a little progress there. And then their third one, very similar in nature, another donut approach, but much larger. This one, I believe, was 80 feet in diameter. Those other two were in the 60s, mid 60s. So this is a very large roundabout. Again, same approach, low cost, use a lot of paint outside, use our structure on the inside. Again, VDOT maintenance, installing this one and that previous one we just looked at, all on their own, no assistance from us. And then another near-term installation, we're doing one up in San Francisco in the Presidio area, so a really nice kind of aesthetic area where we're trying out some new aesthetic approaches to our roundabout to make it a little more appealing in certain areas like this. And we'll be glad to share some updates on that too once we get that installed there. And then just overall business activity, where we kind of operate and who's interested in us and what environments are we dealing with. So the blue stuff is we're kind of all over the country. For the SBIR stuff, there's one hiding back here too in Virginia. Commercial stuff we've got up in Canada, we've got California, we've got Virginia, and we're spreading pretty rapidly. It's a little slower process when you have to deal with, getting community acceptance and such. But I think we're poised to kind of break into the market here pretty well soon. And then you could see that by the business activity. These are folks that are kind of reaching out to us, getting quotes, getting proposals set up. We've kind of got a lot of the country, a little gap in the center here, but I'm sure they'll start to come around. And then we got this one way out here. That's not a mistake. That's Guam. They are actually interested in getting one of our temporary roundabouts for a bridge construction to kind of reroute some traffic. So that would be interesting to go out there and have one installed there. Let's see. Yeah, so that is basically it. We'll just go over a quick summary about what the system offers to hopefully end users and designers. We strive to be low cost. That's critical for us. We don't want to provide something that is not feasible. We want to proliferate the use of these and create safe intersections, efficient intersections throughout the U.S. and in the world. They're customizable and modular, obviously. And so any idea you can come up with, we probably have a solution for it. And so we would accept any challenges there. And again, available in any color or size combination. We've done the red one, obviously, up in Canada, and we primarily do the black and yellow, but we've got every color: green, blue, gray. We've got natural colors, brown, etc. So anything that is required, if you got team colors on a campus or something, anything can go. I know Ohio State would probably like a red and white one as well. They're kitted, transported. It's very simple, easy to stage, close to the intersection. The idea is make it very easy, basic. Anyone can do this. That's our directive there. And then again, attaches over directly to the existing roadway. Has a lot of those benefits where you can drive over it quickly and install these fast to not disrupt people's daily life. So with that, I think we will wrap up the presentation portion and go into questions if anyone has any.
Thanks, Adam. I know Jerry has been answering a ton of questions.
Okay, great.
Yeah, he's got a bunch of them in there. He's been sending his responses to everyone. So
okay, great.
Hopefully folks are able to see that in the question box. It's telling me that they are, but there was one that I think kind of got lost in the mix, and I'll read it off here.
Sure.
One person wanted to know, what inscribed existing radius do you need before additional widening on the existing corners?
That's a good question, and I think kind of outside the purview of what my expertise is. That would be like more for a roundabout design expert, but I could say, I think we've seen some as small as 80 feet, maybe even 60 for the inscribed, which would be the outer diameter of the traffic lane, I believe. So with that in mind, I mean, I think you'd want to have a professional designer kind of give an answer to that one, but that's kind of what we've seen in terms of experience.
Well, that's what we have on this webinar. As far as our
Excellent.
participants are a ton of professional roundabout designers. So
Cool.
one of the things I know you mentioned to me, and I was really busy sending Jerry all these questions that have been coming in, which are great. But did you point out the one that you guys were able to put in where there was no additional right-of-way take? You just basically put it right in the middle of the existing intersection.
Yeah. So we've done, let's see, 3 in Alberta, 2, 6. So we've done, I think, 8 so far, and we have had 0 right of way that we've had to obtain from anybody. All of them have been existing around intersections. No
That's
modification
great.
at all. Yep.
Because I know that has been a big concern as far as cost on putting a roundabout in as the right of way and all of the additional expenses that are involved with that. So
Yeah.
that's
Yep.
wonderful. And your
Yeah.
slide here provides the FHWA technical supervisor who was over the project.
Yep. Yeah. So if anyone has any, design questions or questions about this program or anything, they could reach out to Dr. Zhang. He's a plethora of knowledge, and he's been really leading the charge in the U.S. on the especially mini roundabouts specifically.
So that's great. Now, Jerry, did you want to unmute and add anything?
I guess, I mean, I was kind of listening, but you're right. I was so busy trying to answer questions. I think Adam sounded like he did a good job. There were a lot of questions about um, size and color, kind of the starting questions that we get asked. But I mean, the system is completely modular, so anything goes, at the beginning, and then, it usually comes down to price. The the color is a big driver of cost. Black is cheaper by far than any other color, but we can, that's why you see things mostly black with some color. Although Alberta purchased all red, so it's not that it's prohibitive, it just costs a little more. And people usually start with this system because they're trying to cut cost.
Right.
Another question was about temporary versus permanent. I mean, the thing in Annandale, which this picture that's up there right now was in Annandale, Virginia, they sold that to the community as a temporary solution to a problem, but it's been there now and there's no indication it's ever leaving. So, it's designed to be removable, relocatable. Some people have talked about moving it from spot to spot, down the road as they install other systems or build a bridge, where they need a temporary system, and then you can reinstall it. It's like a Tinker Toy set. So that's a little different than conventional systems as well.
Yeah, and one thing to kind of add to on the color side of thing and aesthetics is that the board actually has kind of like a nice, almost stone-looking texture to it. It's not just like a smooth plastic. And so if you go with like a gray-looking color, it can tend to look a little bit like stone. So that's just another option or consideration that's out there. So they don't just look like smooth plastic. They actually do have some nice texture to it. Makes it look a little more natural outside
I
of the bright
wasn't
yellow.
listening, Adam. Did you talk about the possibility of making it look like cobblestone, or having some
No,
significant
nope.
texture?
I didn't mention that. Yeah, so because we're CNC and everything, we can create pretty much anything. Because we create it in a 3D model and then it goes right into a machine. That file gets uploaded and then boom, you push the button. So what we've considered actually, because out on the East Coast where Jerry is in the Boston area, we had one proposed for Nantucket, and they kind of have some high degree of aesthetic regulation they have there with granite curbs and cobblestone roads and such. And we actually looked at doing a machined in version of a cobblestone. So and that's totally doable, and something we're hoping that provides an extra layer of usability for our product.
Well, thank you both very much for this excellent webinar and the information you've shared.
Mhm.
Hopefully it's given everyone on here a lot of food for thought about how we can drive down costs on roundabout installations, because we know that roundabouts save lives. And I want to thank you for your time today, and I want to be respectful of everyone's time. We've gotten to 3 o'clock. So there were a few additional questions that came into the question box, and I'm going to make sure that those get over to both of our presenters for today. But thank you again, Adam and Jerry, and thank you everyone who participated. And I'm going to go ahead and end our webinar for the day. We hope to see you on a future one. Take care.
Excellent. Thanks, Victoria.
Thank you.
Bye.